Here you go. So, summary of today: constant of proportionality. And constant proportionality is that one value you can use to multiply one quantity to get to the other one. So here, well, let's think about this, right? 1 to 12 would be times 12. 2 to 24, how would that happen? It would be times 12. And 6 to 72 would be times 12. So there is our constant proportionality, right? And we can use this number, and then once you have this, the constant proportionality, it doesn't matter what number. Let's say I gave you the number 88, 145, and I asked you to find the value in inches. Well, all you have to do is multiply by 12, multiply by 12. And that's where the constant proportionality comes in really, really handy, right? No matter what the problem is, because you have it, it makes it so easy to find the other value. Let's see if I can do a better explanation with this one. So, when Davis mixes milk and chocolate, he uses 2 cups of milk with 3 tablespoons of chocolate syrup. Okay, this table shows how to make that particular mixture, right? So, is there a proportional relationship? Well, if there is a proportional relationship, let's find the constant proportionality. Now, the constant proportionality is also known as the unit rate. So its unit rate is a comparison of 2 values, right, with different units. So in here, where one of the values, is 1. So here is what happens when I use 1 cup of milk. How much chocolate syrup do I need? So instead of 3 over 2, let's switch that and write 1.5. Now this, anytime you find this, right, where one of the values is 1, that is going to be our unit rate. So now that I have that, now that I know the unit rate, look what I can do with it. I can go over here and say times 1.5. I can go here and say times 1.5. This was also times 1.5. This was 1 times 1.5. So, and let's just say, and I'm making this up, that I had other values, I don't know, 45 and 96, right? And you have a huge party and you have 45 cups of milk. How much chocolate syrup would you use to keep this at the same flavor, right? The same flavor as when you had 2 cups of milk and 3 cups of chocolate. Well, times 1.5. This one will be times 1.5. So having the unit rate, it makes life so much easier. So let's see if this is correct. 2 times 1.5 is 3. Yeah. 8 times 1.5 is 12. That works. 1 times 1.5 obviously is 1.5. 10 times 1.5 is 15. And the other two that I, that I made up, we don't need to, but I'll just put it anyway. So 45 times 1.5 is 67.5. And 96 times 1.5 is 144. So, is this proportional? Yes, I can use the constant proportionality to check if my table is proportional. And since every value here was multiplied by our unit rate or constant proportionality, this is a yes. What is the so is it a proportional? Yes. What is the constant proportionality? 1.5. Okay. It's easy. Same thing here. When you mix 2 colors of paint in equivalent ratios, the color you get is always the same. So think about this. You mix blue and red. I have no idea what you get when you mix blue and red. Alexa, what do you get when you mix blue paint and red paint?
According to an Alexa Answers contributor, equal parts of blue and red will result in the color purple.
Well, purple. So if I add equal parts, it's purple. So this would be a purple with a more reddish tone to it, right? So blue, if you mix, according to Alexa, if you mix equal parts of blue, so let's say 1 cup of blue plus 1 cup of red, you get purple. But in this case, there's more red, so I wonder how that affects it. You get like a more reddish purple. Yeah. Anyways, now I know that you get purple. So, can you find the constant proportionality? The constant proportionality is this number, right? But it's also found here. That's the line where you find your constant proportionality or the unit rate. Constant proportionality. Okay, so, and obviously, to find this, well, how did the 2 times, what's the relationship here? How did the 2 become a 6? It would be times 3, right? So this would be times 3, and this would be times 3. So if I had 1 cup of blue paint, how many cups of red would I need? I would need red. So if I mix, so again, remember what we said about the other day, equivalent ratio. So we have 2 cups of blue and 6 cups of red. And then over here we got 1 cup of blue with 1 cup, with 3 cups of red. They are equivalent ratios. They're comparing, although numerically they might have different numbers, but the ratio between the 2 colors is the same. So I might not have need that much paint, so I just use 1 cup of blue with 3 cups of red. You might have want to paint a larger area, so you needed 2 cups of blue, 6 cups of red, but your color and my color have been the same. That's done. We answered. So let's go to 5 here. Right off the bat, they give us the constant proportionalities right here. In this line, it's given to us. So anytime you see this line, where this is a 1, right, you can already tell that we're going to go for the unit rate. So it says when you have a triangle and one side measure 1, right, the other side will measure 6. So when we measures a half, and let me take half of that, obviously, it's going to be a little relationship. It's not going to be 6, it's going to be half of that. Well, what's the relationship here? Well, how did the 1 become a 6? It's times 6. So there's my constant proportionality. Every time side A is 1 inch, side B will be 6. Now, what if side A is half an inch? Side B will be 3. So we're going this way. What if I went this way? Well, it wouldn't be multiplied by 6. So something, so if you think about this, let me keep it this way, something, a mystery number here, times 6, going that way, gave me 8. So what times 6 can give? Well, in this case, you can think about it going the other way. If it's going from left to right, right, was times 6, going the other way, it's going to be divided by 6. So take a calculator and go 8 divided by 6. And you get 1 and 1/3. So I'll write that. And I'd rather you leave it as 1 and 1/3 than 1.33333. Okay. What's the constant proportionality? 6. What does that constant proportionality tell you about the triangles? Tells you that for every 1 inch in side length A, side length B will be 6. Will be 6 inches. What is this now? Same thing. Hang on a second. Shit. So we have a table here. Let's just check if it's proportional. And this is what it takes to get the color called Blue Breeze. So, depending on how much you need, if you want the color called Blue Breeze, make sure that every time you have 1 cup of blue, you mix in 3 cups of white. So we can find the constant proportionality in this line. Right? It's just given to us right there. Look, it's being compared to 1. So 1 times 3 is 3 times 3 times 3 times 3. So there's our constant proportionality. Right? So for every 1 cup of blue, we need 3 cups of white. And that's the unit rate. And then Sai, he wants to create another color. but he wants to create it so that's a little bit more heavy on the blue. So notice that here it was 1 blue and 3 white. There's definitely more white, so it's going to be a little light blue. This one, on this table, he wants to create something that's a little bit darker on the blue side. Complete the first row of B to create a possible mixture for C. So complete the first row. So you're adding more blue, so why don't we keep the same amount of I think he wants to create, so I'm free to pick whatever I want. Alright, so let's pick 2. Make life easy. So notice that here I have 4 cups of blue and 2, so I have less white and more blue, pink wise, right? So this is definitely going to get a deeper shade of blue. So what's the relationship? How does this get to this? Well, scale factor, right? The actual scale factor, constant proportionality is actually a half. 4 times a half is 2, so here I'm going to multiply half. 7 times a half is 3.5. Something times a half gave you 1, so obviously that's 2. And then 12 times a half gives me 6. Where did I get this to? I made it up. Right? I made it up knowing that whatever number I put there, it had to be less than the 4 cups of blue because we wanted a darker shade of blue. So I couldn't put, let's say, 6, 7, I don't believe it is 7, 8, 9 cups of white. I needed to have more blue, okay, to keep it a darker shade. Jeez. 10, spiral. Ugh. Select all the scales that are equivalent to the scale 1 centimeter to 5 meters. So what we can do here is put this guy here, like this. 1 centimeter to 5 meters. Then let's do the first one. Half a centimeter and 2.5 meters. Well, let's see if they're the same. Well, first of all, the units are the same: centimeter, centimeter. At the bottom, meters and meters. So we're good there. You want to cross multiply? We can. 1 times 2.5 is 2.5. Right? 1 times 2.5. And what's half of 5? That's also 2.5. So this one is the same. Alright, so that one was good. Let's try 1 centimeter to 5 kilometers. Okay, so there's a little bit of work to do here. 1 centimeters to 5 kilometers. Are they the same? Well, first of all, we have an issue. Centimeters and centimeters on top, so that's okay. But the bottom, it says meters and kilometers, so we have to change. So 1 kilometer, you should know this, it's 1,000 meters. So instead of writing 5 kilometers, I'm going to write 5,000 meters because I had to change the unit. Now, are they the same? Yeah, of course they're the same. We're on 3, 5 centimeters to 1 kilometer, but instead of writing 1 kilometer, I'm going to write 1,000 meters. So, is 1 over 5 and 5 over 1,000 the same thing? Well, it doesn't look like it is. If you cross multiply these two, you get 1,000. And 5 times 5 is 25, and you can clearly tell they're not equal. So, C's out. A couple of things here. Besides setting up the proportion, you have to make sure to change the units so that they're equal. So C was not it. D, 5 centimeters to 25 meters. Now you can cross multiply, or you can simplify this, or you can say, hey, how did the 1 become 5 times 5? And at the bottom, is it times 5? Yes, it is. So it's just an equivalent ratio, right? So 1 over 5 is the same thing as 5 over 25. You could have simplified 5 over 25 and seen that it was equal to 1 over 5. So this guy here is the same. We have the last one. No, we have one more. Yeah. What about 10 centimeters to 50 meters? Is that the same as 1 centimeter to 5 meters? Well, let's Oh wait, let's simplify. One time, sorry, let's cross multiply. 1 times 50 is 50. And then 50 times 10 is 50. Oh, they're the same. Are the units, first of all, let me go back a little bit. Are all the units the same? Top was centimeters, and the bottom was meters and meters. Good. So you just saw the cross multiplying work. What if I simplified 10 and 50? Well, I would have gotten 1 over 5. Is 1 over 5 that ratio 1 over 5 on the right side the same as the ratio 1 over 5 on the left? Yes, they are. So this would have worked as well. 4 over 7. Listen, I prefer writing as a function. I'm going to write each of these as a function. 16 over 21, 7 over 4, 20 over 35, and 6 over 9. Now what I'm going to do next is simplify each of these. I'm not going to set them equal to each other and do 5 different proportions. 4 over 7 is already simplified. 8 over 15, can I simplify that any further? Can you think of a number I can divide 8 and 15? Common factors, none. So that's already simplified. If that's already simplified, is 4 over 7 and 8 over 15 the same? Nope. That's not it. 16 over 28, is that simplified? No, it's not. So let's simplify. 16, we can divide by 4 and by 4. 16 divided by 4 is 4. 28 divided by 4 is 7. Oh, look at that. This is the same thing as that one. So this one, yes. C, it's 7 over 4. Order does matter. 7 over 4 is not the same thing as 4 over 7. So that's not it. D, let's simplify that. Divide by 5 and divide by 5. 20 divided by 5 is 4. 35 divided by 5 is 7. Look at that. 4 over 7 and 4 over 7. So this one's a yes. Last one, 6 over 9, divide by 3 at the top and the bottom by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Is 2/3 and 4/7 the same? It is not. So only B and D were equal to 4 over 7. Okay. That's really it.